I, this, I use this on a whiteboard because over the past 12 months it's changed 7 times. But it actually now it's kind of become imprinted in the architecture of what we're doing for exploration. So pretty soon I'll be able to erase this board because there'll be formalized charts out of headquarters that kind of reflect a lot of this. But it shows a pathway where I start doing the ground research that you're going to see some of it here today. How I take that research then in my first opportunity to prove it out, whether it's hardware or the biology on the International Space Station in low Earth orbit. And then it's as we move away from low Earth orbit, I start getting to the gateway around cislunar space. How do I utilize that? Then at the surface of the moon, then on the missions itself to Mars, and then eventually on the Mars surface, right? So what am I trying to do? Ultimately, the food system that's on the International Space Station builds on a legacy of food systems that we've used from manned space going back to the first time that an American astronaut ate anything in space, and that was a tube of applesauce that John Glenn ate. At the time, they didn't even know if you'd be able to eat. He basically ate this applesauce, swallowed some sugar pills and water, and everything went well, so we knew we could eat. And that's evolved over time. And right now, from that point on, all the way up till today, the food that the astronauts consume is all prepackaged food that's prepared at the Johnson Space Center and is sent up to space. So it's all things that have to be shipped up to space, and that means the only way you can really do that efficiently and reliably is when we're relatively close to the Earth, where the food source is, and when we can do it in such a way that we can afford to take that mass up with us. So as we start getting further and further away from the Earth, we can no longer really depend on shipping these vast quantities of food, especially when I start talking about permanent residence on the surface of Mars. For the interim, it's always going to be prepackaged. When we first even get to the moon, it's going to be prepackaged food. The other challenge that comes with why you need to supplement the diet is the fact that when I start talking about missions to Mars, I'm talking missions in excess of 3 years potentially. And that means that certain vitamins and nutrients inherent in that food are going to degrade over time. Just food has a shelf life whether it's here on the Earth or in space. We're trying to do everything we can to extend that shelf life, to buy us margin, but ultimately we know we have to supplement the diet. So the first steps are going to be all about dietary supplementation. And that means pick and eat types of plant crops for the most part. Pick and eat crops require no processing, no preparation. Salad type crops that the crew can just pick and consume makes it the easiest thing for them to start off with, especially since on the International Space Station there is no oven, there is no refrigerator, there's no processing or kitchen equipment. The only time we were, in the history of the space program, we were fortunate to have that capability was back on Skylab, but that was in the early 70s. We do not have that now. So going forward, it's going to be pick and eat crops, and then we're going to eventually, when I start talking about residing on the surface of the moon long term or on Mars, I'm going to be adding to that staple crops, things that will provide calories more so than just basic nutrients. Things like wheat, rice, potatoes, sweet potatoes, a variety of vegetables like that now I'm going to have to process them and prepare them and cook them. So along the way, to make this whole vision become real, there's certain challenges that we have to address in terms of just growing the plants in the environments that we're exposing them to. Microgravity environment on the International Space Station, at first we weren't sure how the plants would grow. How would they react to that microgravity experience? Pretty much everything we've grown so far has reacted well on the standpoint that we can grow it and consume it. We're being challenged now to look at increasing the variety of plants that we can grow in space, because ultimately when I start talking about feeding crews, I want to give them as much variety in terms of their diet as possible. Everything that we grow it goes through the lens of what will the crew eat and how much of the key nutrients that they need will they provide. So we're very selective in the types of crops we grow, and we want to increase the variety as much as possible. Up till now, it's been a lot of leafy greens. We're getting ready to grow our first fruiting crops in space, and that will be peppers. We're looking at tomatoes and expanding that all out in time. So the big challenge in microgravity was what's the response of the plants? So far, it's been fairly good. We've got good results, but there's a challenge in getting water and air to the root zone of plants that we don't have in unit gravity here on Earth. And how do I make sure that the plants have access to water and air in the right amounts that they need to grow and thrive. And what we've seen with just of our experiments to date is that water behaves very different. In some cases there'll be regions within a certain growth area where there'll be a lot of water. The plants will have too much water. Certain areas there won't be any water, there's not enough. So we're trying to come up with new watering strategies, and I'd say that's probably the biggest technical challenge we have now. We also have issues with lighting, trying to optimize the lighting. Everything we're looking at doing really needs to be sustainable, minimizing the resources we bring to bear so that we can continue to do this with a small amount of space, power, and consumables that we'll have. And in that way, it ties very closely into controlled environment agriculture that we do here on Earth. A lot of the time we spend here, I would say 30% of our time, is going to controlled environment agriculture conferences, sharing what we do here with our space research, along with what people are trying to do terrestrially to feed the planet in terms of climate change, hostile environments. There's a lot of commonality here. So again, low Earth orbit, ISS, we're looking basically about some of the primary challenges, like how do I water and grow the plants. Now when I get away from the magnetosphere that protects us from radiation exposure in low Earth orbit, now I have this new, somewhat unknown challenge, and what is the radiation environment that we're going to be exposing both the crew and the plants to, going to do the performance of the plants. That's something we've never done before. So there's a variety of opinions on it. Suffice it to say, we're going to have to prove it and demonstrate. And that's not only how will the plants grow, it's will the seeds that we bring along the way, will they germinate? Is there going to be some germination percentage flaw that we're going to have to make up for, send more seeds, etc. We'll be learning that, hopefully in cislunar space, whether there'll actually be enough volume to put a plant chamber on the gateway is under, is somewhat subject to doubt. But the purpose here initially will be not to grow crops for food. It'll be just to do it for research. How do these plants grow in this environment? So initially, when I step away from low Earth orbit, I'm going to be looking at a research perspective. We'll likely be doing that, if not on the gateway, we'll definitely be doing it on the surface of the moon early on. And then as things expand on the moon, and again, this is a somewhat to be determined function, if we start seeing an explosion of commercial activity on the moon as they start to find water and mine water, more people going, we'll be needing to augment the food there sooner rather than later. In either way, we'll be using the moon as an analog for Mars. The systems that we're going to eventually take to Mars, we're going to be demonstrating on the moon first. It makes perfect sense to go to the moon first. I know a lot of people were somewhat disappointed that why are we going back to the moon? You don't want to go to Mars first and practice something for the first time. When you leave and head to Mars, that's it. Whatever you forgot to bring with you, you don't get. Just a quick thing, if I'm on the surface of the moon, round-trip communications is roughly 2.5 seconds, depending on the orbital positioning of Mars and the Earth. When you're talking about trying to communicate on the surface of Mars with a colony there, it could be as long as 44 minutes for a round-trip communication. So the whole paradigm we work under, where we have this close access to Earth, I could be back from the space station if there was a problem in a matter of hours. I'm looking at on the moon, or on the moon it's days, on Mars it could be months, right? So there's a whole paradigm affecting how we shift in terms of how we actually devise and develop our systems. From a plant perspective, though, ultimately we're looking at the end state of having self-serving colonies on Mars and on the moon, where I can actually have a bioregenerative life support system where I can basically take the air that we breathe, use plants as a filter for that air, maintain something as sustainable and closed loop as possible. So with the time I have left, any questions?